Section, we're recording now. We're live. And this is all about polygons. Go. So these are polygons. Those shapes are polygons. And here are some polygons. So looking at that picture, and this is a picture I cut and pasted from your book. But who can tell me, no, go back. You don't know that yet, okay? Who can tell me what a polygon is based on that picture? Give me some words to describe a polygon. What's a polygon? Go ahead, Sahana. A closed shape. Well, then, if it's a closed shape, why wouldn't, if it's just a closed shape, why isn't this working? Why wouldn't that oval thing be a polygon? What's a closed shape got to be made? Oh, I know why it's not working, because this isn't plugged in. Why that circular thing, if you just say it's a closed shape, why wouldn't that circular thing be a polygon? What's it got to be made up out of? Angles and what?
Straight edges.
Straight edges, or what's another word for straight edges? Segments, okay? So it looks like an enclosed shape made up of segments. So if it is a closed shape made up of segments, then why wouldn't this one be a polygon? This is a closed shape made up of segments, right? What?
Did you want the definition?
Yeah, the definition popped up, okay? So I don't know how to make that better, but a polygon is a closed figure in a plane formed by connecting line segments endpoint to endpoint. So see, this one is not connected endpoint to endpoint, right? With each segment intersecting exactly two others, each line segment is called a side of the polygon. Each endpoint where the sides meet is called a vertex, okay? So these ones intersect more than once, or it's not connected endpoint to endpoint. This is not made out of straight edges, neither is this. And this one intersects in more than one place, even though it is a closed shape. Do you want a minute to write that down? Okay. Go ahead. So I gotta pause now. That's my pulpit. I have to make a mark on here, otherwise it won't keep that in my notes. Okay. So moving on. What's my next slide? So when you have a polygon, am I recording? I'm recording. When you have a polygon, these things are called consecutive angles. What does consecutive mean? One after another, right? So A and E are consecutive angles. A, B, C, D are consecutive angles. So these are the angles. The points are the vertices, and these things in order are the sides. Who can name one pair of consecutive sides for me? Give me one pair of consecutive sides. One pair. Go ahead, Drake.
A, B, and B, C.
A, B, those aren't, oh yeah, A, B, and B, C is a pair of consecutive. They have to be right next to each other, okay? Good, all right. So, and then we have all these names of things. Whether you write them all down or not, I think you know what a triangle is, right? Polygon with three sides, these are types of polygons. So a polygon with three sides is a triangle, four sides is a quadrilateral, right? So if you go down and hang out in the quad, how many sides does it have? If you have an Audi Quattro, how many wheel drives do you have? Four, right? I have an Audi. No, actually I have an E. So Audi Quadrilateral. Pentagon, they have 5 sides. They have those in Washington, D.C. Hexagon, that's 6 sides. I think most of you know that. Heptagon is 7 sides. 8 sides is an octagon. 9 sides is a nonagon. 10 sides, decagon. 11 is an undecagon. 12 is a dodecagon, and n is an n-gon. Am I going to test you on this? Probably not, but you should know what most of those are, okay? Okay? Tell me when I can carry on. Whoops. Don't do that yet. Don't look at that man in the curtain. Okay. Talking to the Wizard of Oz. All right. Can I move on? Okay. And this is, I cut and pasted all this stuff, most of this stuff out of your book. Naming polygons. When you name a polygon, you name it by consecutive vertices, okay? So, and you could start anywhere you want. So I could name this A, B. Oh, that's wrong. Oh, A, sorry, I thought that was a B. A, B, C, D, E. I could also name it B, C, D, E, A, right? I could also name it D, E, A. I could go this way. It doesn't matter which way you go, as long as you go in order of the points. I cannot name it A, C, B, D, E, right? So you have to go in order of the points. So this triangle could be named ABC. Who could give me another name for this triangle? Go ahead, Kim. CBA, okay, or CAB, right? So all those things are, so you have to name it in order. So moving on to the next thing that I have here, diagonals of a polygon, okay? A diagonal is a line segment that connects two consecutive, a diagonal of a polygon is a line segment that connects two non-consecutive vertices. A convex polygon, a polygon is convex if no diagonal is outside a polygon, and a polygon is concave if at least one diagonal is outside the polygon. I'll give you some examples. Both of these are convex polygons, and if I were going to draw in the diagonals, okay, they look like, here's one diagonal of that polygon. There's another diagonal of that polygon. There's another diagonal of that polygon. There's another one. Oh, it's making a cool star shape, you know. But does a triangle have any diagonals? Triangle can't have any diagonals because it has to, a diagonal is a line that segment that connects two non-consecutive vertices. So I would have to find another vertex that's not right next to it, right? And I don't have one. So moving on, I know, so this one here is, this is a convex polygon. Concave polygon, because I can draw a diagonal outside of the polygon. See that? If I could connect the diagonal outside of the polygon, then it's concave. You understand? You're looking a little confused. So even though it has diagonals inside the polygon as well, right? Like these ones and this one and so on, it's concave because it's basically it's got a dent in it, and it's called concave. If it doesn't have a dent in it, then it's convex. Like in this one, concave or convex? Convex. So this one, now it's hard to see with all my writing all over it, so I'm going to get rid of those things, okay? So this one is concave. Concave, because you could draw a diagonal outside of the polygon. This one is convex, because there's no diagonals outside of the polygon, and there's no dents in it. Questions so far? Can I move on? Still drawing? Okay. Moving on. Moving on. What are congruent polygons? Who can tell me what congruent polygons are? What do you think? What do you think? What do you think congruent polygons are, Ian? You don't know? If they say two shapes are congruent, what does that mean? Same size and shape. That's what basically what congruent means, same size and shape. But polygons are congruent if and only if all congruent sides and vertices are congruent. Okay? Or really that shouldn't say vertices, I believe that should say angles. I messed up when I wrote this, okay? That should say angle. A vertex is just a point, so points can't be congruent. That should say angles. Okay? All right, very. So polygons are congruent if and only if all corresponding sides and angles are congruent. So P lines up with T. You see that? And this side in between P and M goes with this side between E and T. So P, wait, I can't see how many marks. P goes with E, T goes with what? M, and side PM goes with side ET. Okay. Sorry. ET. So when you write a congruent statement, you have to write it. You could tell by the congruent statement which goes with what. So because I spelled this polygon CAMP, that must mean that angle C goes with angle what on this one? S over here. And notice there's one hash mark on C and one hash mark on S. That means those two things are congruent. Side MP on this one would be congruent to side MP would be congruent to TE or ET, right? Doesn't really matter, but so you can tell by the statement as well as by the figure what goes with what. So I want to show you something else, okay? So where's that next slide? Always name the congruent polygons in the order of their corresponding sides and vertices. Whoops. I want to go back, okay? If you want to write that down, you can. Do you want to write that down? You don't have to. Always name the congruent polygon by vertices, sides, and angle. Well, vertices is fine. Okay? Do you understand what corresponding means? Corresponding means they line up together. Okay, so corresponding side, what side goes with CP? What side goes with CP? SE. You can tell it by the picture, but you can also tell it by the word. CP goes with SE, right? So if side CP goes with side SE right there. Okay. Moving on. Look at this picture. So you look at this picture, which polygon is congruent to A, B, C, D, E? Which of these three is congruent to A, B, C, D, E? A, B, C, D, E. What do you think, Kareem?
I think
Name it in the correct.
NPQL.
Very good. Okay. You have to name it in the correct order as well, right? So, this side isn't congruent to anything over here. So since every part has to be congruent, then you can throw away this one because it doesn't work, right? Because this side doesn't show it's congruent to anything. This one, it only shows one angle congruent to this angle, so you can't say this one. This one shows all the sides and angles are congruent. And because this has 2 marks and this has 2 marks, this angle must go with this angle, right? And since this has 2 marks and this has 2 marks, this side has to go with this side has to go with this side or this side. So you can say that A, B, C, D is congruent to, I think you could either say N, P, Q, L, M, or I could go this way too, couldn't I? Because then everything would still line up. Or N, M, L, Q, P. But if you name this one like M, L, Q, P, N, it wouldn't be exactly correct because you wouldn't be matching up the corresponding sides. Get that? Okay. So if you're given this, I don't have a slide that goes with it. If you were given this MNOPQ is congruent to party, yay, okay? List all the congruent sides. Give me one pair of congruent angles. What would angle M be congruent to? Angle P, okay? And you don't even know what this looks like, right? But what would angle T go with? Angle T, uh-oh. Oh, I have two P's, huh? Oh, yeah, this T goes with this P. I messed up because I have P's in both ones, but that's okay. And so on. What would side MQ be congruent to? MQ would have to go with, MQ, sorry, would have to go with PY, right? And so on. So PY. Okay, you can do it, Mr. Leader. Head, right? With PY. So if you're given a statement like this and it says it's congruent, you have to assume that this lines up with this. Side MN goes with side PA, NO goes with AR, and so on and so on. Questions? Okay. And we're going to move on. Can I move on? Okay. What's next? Okay, and now we're just going to talk about three special polygons. Who can tell me what an equilateral, these are equilateral polygons. These are not equilateral polygons. Who can give me a definition of an equilateral polygon? Go ahead over there, Ben.
When all sides of the polygon are the same.
Very good. Okay. Write a definition. An equilateral polygon is a polygon with all congruent, I'm going to use this symbol, congruent sides. Easy enough? Write it down. Equilateral. If you're playing football and you throw a lateral, where do you throw the lateral? To the side, right? Where are your lats? Where's your lats? If you're waiting, where's your lats? Any swimmers in here? Who's a swimmer? That's where you get sore, right? You get really good lats if you're a swimmer, right? Your lats are your side, the muscles right here and below your shoulders on the sides. Okay? So lateral means from the side. Equilateral polygon. You don't have to draw the pictures, just as long as you know what an equilateral polygon is. Okay? Moving on. What do you think an equiangular polygon is? Tough one. Go ahead, Ryan.
They all have the
Equal angles, okay? Equal angles, equal angles, equal angles, right? Not equal angles, not equal angles, not equal angles, not equal angles. So equiangular polygon is a polygon with all, what's wrong, Kira? Equiangular polygon is a polygon with all congruent sides. I say one thing and something else comes out, okay? Angles! Sorry. Whoa. Angles. I'm thinking ahead, or I'm thinking behind, I don't know. All right. We're good? One more and then we're done. And then you can start on your work and stuff, okay? So last one we got is a regular polygon. Look at the regular polygons. Look at the non-regular polygons. Who can give me a definition, kind of thinking about what we just said? What is a regular polygon? Go ahead there, James.
A polygon with all or congruent angles and sides.
Very good. A polygon basically where all the angles and all the sides are congruent. Or you could say a polygon that is both equiangular and equilateral. Either way is fine. Okay? So a regular polygon, there's lots of regular polygons. congruent, so all sides and angles are congruent, okay? And that's about it, all right? So, you ready for your homework? There we go. Homework. Look at how organized I am. And your homework is 100% totally utterly fantastic. There it is. And you can start on that while I check some more homework sets and things like that. Let's pause this.